Dear friends, welcome to Quest for Knowledge. In today's video, we will solve basic problems based on probability. So let's begin today's video. When we talk about probability of any event, it is given by a ratio Ne upon Ns, where Ne represent total number of outcomes in favor of event and Ns represents total number of possible outcomes. So total number of possible outcomes is also known as sample space and it is denoted by S. So for a dice we can have numbers 1 to 6. So here number of sample space is 6. For a coin we can have head or tail. So number of sample space will be 2. If 2 coins are tossed, then sample space will contain 2 heads, 1 head, then tail, tail, then head, both tail. So in case of 2 coins, number of sample space will be 4, right? So when we talk about any event, if event is impossible to happen, probability of that event is 0. If event is 100% possible, then probability of that particular event will be 1. So we can say probability of any event lies between 0 and 1. Second point we have, when we add probability of happening any event with probability of not happening that event, we get 1, right? So we have formula PE plus PE dash equals to 1. Let's solve some of the problems based on probability. So first question we have, find the probability of one head when 2 coins are tossed simultaneously. So in this case, number of sample space will be 4 as we have discussed. Head head, head tail, tail head and both tails, right? So number of sample space is 4. Here event is 1 head. So here number of event is 2 because from sample space we have HT and TH. In these two case we have 1 head. So NE will be 2. So to calculate probability of that event, and here event is 1 head, value will be Ne upon Ns. So 2 upon 4. 2 upon 4 is equal to half. So probability of 1 head is half when 2 coins are tossed, right? Next question we have is, find the probability of at least 1 head when 2 coins are tossed simultaneously. So here event is at least 1 head, right? We must have 1 head. We can have more than 1 head because it is given at least, right? So number of sample space will be same, 4. Now number of outcomes in favor of at least 1 head are HH, HT and TH. In these 3 cases, we have at least 1 head. So probability of getting at least 1 head will be 3 upon 4. So in this way, we can calculate probability of any event, right? Next question we have is, 3 coins are tossed once. Find the probability of at least 2 heads, right? So in this case, 3 coins are tossed. So number of sample space will be 8 because in 3 coins we have 2 choices. Either we can get head or tail. So as we already discussed in permutation, how to calculate number of arrangements. So here number of sample space will be 2 to the power 3 and that is 8. And here you can see the sample space. We can have triple heads or we can have HHT, we can have HTH and so on, right? So we can have 8 possible outcomes. Now here event is at least 2 heads. From sample space you can see we have 4 outcomes in favor of this particular event. triple H, HHT, HTH and THH. In these 4 cases we have at least 2 heads. So we can find probability by dividing 4 by 8 and that is equal to half. So probability of at least 2 head is half when 3 coins are tossed, right? Next question, we have 4 coins are tossed once. Now in this case we have 4 coins. Find the probability of at least 1 tail. Now in case of 4 coins, possible outcomes will be 2 to the power 4 and that is 16. So number of sample space will be 16. Here you can see the possible outcomes. We can have 4 heads, we can have triple head, then tail and so on, right? So in this manner we can have 16 outcomes. Now event is getting at least 1 tail. So accept this particular outcome. All are in favor of at least 1 tail. In all outcomes we have at least 1 tail. So there are 15 outcomes in favor of this event. Now the probability of getting at least 1 tail will be 15 upon 16 as the formula is NE upon NS, right? Hope this particular solution is clear. Next question is find the probability of getting a multiple of 3 when 1 dice is thrown once, right? So in this case we have 1 dice. In case of 1 dice, possible outcomes are 6. We can have 1, 2, 3, 4, 5, 6. So number of sample space will be 6. Now here event is getting a multiple of 3. From sample space, multiple of 3 are 3 and 6. So outcomes in favor of event is 2. Now probability of getting a multiple of 3 will be 2 upon 6 and that is 1 upon 3. So in this way we can calculate probability of getting a multiple of 3, right? Next question we have is find the probability that sum on both faces is 9 when 2 dice are thrown. Here we have 2 dice. So possible outcome will be 36. In case of 1 dice we have 6 outcomes. Now in this case we have 2 dice. So possible outcome will be 6 square and that is 36. We can have 1 comma 1, 1 comma 2, 1 comma 3 and so on. So possible outcomes are 36. Now here event is sum on both faces is 9. So here outcomes in favor of event are 4. Here we can have 3 or 6 because sum of 3 and 6 is 9. We can have 4, 5. We can have 5, 4 or 6, 3. In these 4 outcomes, sum on both faces is 9. So these 4 are in favor of event. Now to find probability of getting sum is 9 will be 4 upon 36 and that is equal to 1 upon 9, right? Next question we have 2 dice are thrown. Find the probability of getting an odd number on one and a multiple of 3 on the other. So again we have 2 dice, number of sample spaces will be 36. So we can have these outcomes. Now event is getting an odd number on one and multiple of 3 on the other. So these are the outcome where one is odd number and second is multiple of 3. In this case 1 comma 3, 1 is odd and 3 is multiple of 3. 1 comma 6, 1 is odd, 6 is multiple of 3. 3 comma 1, 1 is odd and 3 is multiple of 3. 3 comma 3, 1 is odd, 1 is multiple of 3 and so on. So in total we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 outcomes are in favor of event, and here event is getting an odd number on one and multiple of 3 on the other. So probability will be 11 upon 36 of getting an odd number on one and multiple of 3 on the other, right? Next question is, a box contains 5 red, 4 green, 6 black balls. If 3 balls are drawn at random, find the probability that all balls are red color. So here event is getting all balls red. Here we are taking 3 balls. Total balls are 5 plus 4 plus 6, and that is 15. So in total we have 15 balls. So we can select 3 balls out of 15, and this will give number of sample space. As we already discussed in combination how to count number of ways. So here we are selecting 3 balls out of 15, and this will give number of possible outcomes. Now event is getting 3 balls of red color. So in total we have 5 red balls. So we are selecting 3 red balls out of 5, and this will be outcomes in favor of getting all 3 ball red, right? So probability of getting all balls red will be possible outcomes in favor of getting red ball upon number of sample space. So it will be 5C3 upon 15C3. Now in combination, we have discussed how to calculate combination. So after calculating these values, value will be 2 upon 91. So probability of getting all balls red is 2 upon 91, right? So if you have any doubt how to calculate combination value, you can go through the combination video, and link to that video is given in the description box. Next question we have is, a box contains 5 red, 4 green and 6 black balls. If 3 balls are drawn at random, find the probability that 1 ball is red and 2 balls are green. So here event is getting 3 balls. Out of 3 balls, 1 ball is red and 2 balls are green. So in total we have 15 balls. Number of sample space will be selecting any 3 balls out of 15. So it will be 15C3. Now outcomes in favor of event of getting 1 ball red and 2 balls are green is given by 5C1. We have 5 red ball and we are selecting 1 out of 5 red ball. We have 4 green balls and we are selecting 2 green balls. So we have discussed this kind of combination in combination video. You can refer the video. Now probability of getting 1 red and 2 balls green will be outcomes in favor of event upon number of sample space, and answer will be 5C1 into 4C2, because these value will give number of ways to select 1 red and 2 green balls, right? Upon 15C3, this is the value of total outcomes. Now after calculating these values, answer will be 6 upon 91. So probability of getting 1 ball red and 2 green is 6 upon 91. So in this way we can calculate probability of any event, right? If you have any doubt, any query in any of the questions, you can write me in the comment box. Thank you for watching this video till the end.